Keep quiet. Hey.
Okay, I'll get started once everyone settles down and um yeah, okay.
Everyone
Yeah.
sit down. That's the instruction. Why you?
Yeah, okay. I think we're ready to start now. Today we moved on to a science topic, and it's today's topic is on properties of matter and chemical and physical reactions.
All right. Today is science. As you can see.
So first, we will learn about the properties of matter by watching this video. We'll learn about mass, volume, density, and more. So here is the video.
Jeffrey, delivery!
Hey, Mom.
Hi,
Dr.
Jeff's
Jeff's
mom.
mom.
I was cleaning out the garage and I found this box with your name on it.
Yeah, so that was the video about the properties of matter. And the next slides, we will review the concepts. So matter is anything that has mass and volume. And matter has three forms. There's solid, there are liquid, and there are gases. And they can change from one form to another. Everything that we can see and touch around us are matter, like air, water, living organisms are all matter. And matter is not created or destroyed. It only changes form. And this is called the law of conservation of mass. What it basically means is that matter can only change between solids, liquids, and gases. Solid can turn into liquid by melting, and water can turn into gas by boiling. Here are some properties of matter that we looked at. Matters have unique properties, so we can distinguish them by their properties. So there is density. We are looking at whether an object sinks or floats. There is the shapes. There's the mass. There's the texture, the color, magnetism, temperature, volume or length, solid, liquid, gas, all the states of matter, their melting points, boiling points. All of these are different types of physical properties. We can look at them and test each physical properties. So let's look at how we can measure mass. Mass was, again, one of the properties, physical properties, and it is the amount of matter in an object. How much stuff is inside an object is called a mass. And mass does not change across locations. So mass is the same on Earth, on the moon, on Mars, or in space. And it is important to know that mass is not the same as weight. So weight, do you guys know when you guys stepped on the scale to measure your weight? That is not the measure of your mass, and weight actually depends on gravity. So weight is when gravity pulls you down, but mass does not change and does not depend on gravity. Mass is always the same. And mass is measured in grams or kilograms or tons. So 1 kilogram is 1,000 grams. There's also units smaller than grams, which is called milligrams. 1 gram is 1,000 milligrams, and 1 ton is 1,000 kilograms. And mass is measured by this thing called the beam balance. A scale is for the weight, it's not by the scale. And this object is called the beam balance. So we use beam balances to measure the mass, and here is a video showing you how to do that.
Old Spice Super Hydration Body Wash. The sweet scent of a honeymooning feeling.
And that was how you would use the beam balance to measure the mass. And always remember, scale is for the weight, and it is not for measuring mass. Now let's move on to volume. And volume is how much space an object has. For liquids, volume is measured in milliliters or liters. 1 liter is 1,000 milliliters. And for solids, it is measured in cubic centimeters or cubic meters. So can you guys find the volume of this box over here on the left? It's stated here. The cuboid volume is width times length times the height. So it's 6 times 10 times 5, which is 300 cubic centimeters, because it's in centimeters. Here on the right, can you see the volume of this liquid? Here it says the mark lies around 80. So the liquid volume is 80 milliliters. You can see this beaker is measured in milliliters. Did everyone understand how to measure the volume of a solid and a liquid? Okay, if there are no questions, to move on to the instruments for measuring volume. So all these are different types of instruments for measuring volume, but one important note is that beakers are less precise, meaning that they are not as exact as some of the other ones, like graduated cylinder, syringe, burette, pipette, or volumetric flask. All of these are more precise than the beaker. Now that we have talked about mass and volume, now it's a good time to talk about another physical property related called the density. Density is how tightly packed matter is. It is the amount of mass in a given space. So let's look at this left object, which has a green filling. You can see that the green filling is way more spread out. This means that the mass in this space is less than the mass on this space on the right. In this object on the right, you can see that the green objects are tightly packed. That means it is high of density. And on the left, it is low density. And over here, this picture compares the density of water and different types of objects. So cork, you can see, floats on water. It completely floats. So you can tell that cork is less dense than water. On the second one, we put a piece of wood in water. And you can see that it still floats in water, but partially floats because some parts of it sink. That means it is still less dense than water, but more dense than the cork. You can see it sinks more. If it is more dense, that means it sinks in that another medium. So in this case, it sinks in water. You can see with aluminum that aluminum is underneath the water. It sinks. So sinks meaning more dense. If it sinks in water, that means the aluminum is more dense than water. So that was density. And here, this is how you would measure a density when you're in a test. So when you're asked to find density, you divide mass by volume. This is because density, by definition, is how much mass is in a certain amount of volume. So let's have an example here, a really quick example. In this picture, you can see for 20-gram mass that takes up a volume of 5 cubic centimeters, the density is, well, the mass is 20 grams, and the volume is 5 cubic centimeters. You divide 20 by 5, and the answer is 4. And then here, the unit is grams per cubic centimeters. So 4 grams per cubic centimeters. That's how you would find the density. Is everything clear? Does anyone have a question so far? No questions? Okay. We can move on to the next physical property. It's called magnetism. And magnetism is the ability of a material to be attracted by a magnet. And this helps us distinguish metals such as iron, cobalt, nickel, and etc. All of these are metals, and most metals are attracted to magnets. Here it is showing a magnetic field. You can see magnetic force includes attraction and repulsion. Let's look at the next physical property called solubility. And solubility describes how well a substance can be dissolved. Some substances can be easily dissolved by the water and others may not. So sugar is soluble in water. And in this case, it forms a complete solution. Sugar is the solute. Water is the solvent. And after they are mixed together, the whole solution is the sugar water. And you can classify certain objects by using this property of solubility. If you know that some object is soluble in water and other object is not, then you can tell which is which. So now that we have looked at different physical properties, let's practice some BEC science tests. So these questions are directed from the BEC science exam. So here is one example question. Which of the following substances are matter? Which of these are matter? Is it hydrogen? Is it air? Or is it stone? I heard a lot of people saying A. So is it really A? Let's look at 1 and 2 only. So hydrogen and air. Yes, both of these are matter. So, but we would need to identify all of them. So is stone matter? Do you guys think stone is matter or not matter? So stone is a solid, so it is matter. So yes, hydrogen is matter, air is matter, and stone is matter. So the correct answer for this is D, 1, 2, and 3, because all of these are matter. So everything around us that we can see and touch are matter. So it's all of the above. And answer is D. Let's look at this question. The instrument that can be used to measure accurately the mass of a substance is yes, that is right. A is the correct answer. The beam balance. So here, I put the different options here. The beam balance, like you guys said, is what we use to measure mass. And this also talked about the spring balance, the Eureka can, and the measuring cylinder. So here, Eureka can is where you put a solid and you displace certain amount of water to measure the solid's volume. Since a solid is irregular, you cannot measure by width times length times height. You put it in water, and the amount of water that it displaces is the rock's volume. It also talked about this force meter, which is used to measure force of gravity. So it is measuring the weight. But now let's move on to this next question. An aluminum cube of side 2 meters has a mass of 24 kilograms. So 2 meters and 24 kilograms. Determine the density of the aluminum. So we are trying to find the density. It says a cube of a side of 2 meters. So it is not C for this one, because let's go through this process. Cube of side 2 meters, that means a cube has all the same side lengths. So we know that the length, the width, and the height are all 2 meters. And we find the volume to be 2 times 2 times 2, which is 8. And remember, density is equal to mass over volume. We found volume to be 8, and the mass is given to be 24 kilograms. So 24 divided by 8 is equal to 3. And the unit is kilograms per cubic meters. Yes, that's right. So the answer is A for this one. So does everyone understand how to find the volume and the mass and the density?
Yes.
Okay, yeah, I hope this is clear, and I hope everyone is able to find a density of a certain object given its volume and mass. Okay. If you're ready, now let's move on to this second video, and this will be shorter, since it covers only 2 topics, the chemical and physical changes. Let's look at this video for.
Come on, Soap! Can't you come out any faster? I got a dish deadline.
Hey, Izzy, what's going on?
Me and Bert tried to experiment. It was a total bust.
Well, don't blame me. It's not my fault.
I mean, literally, it busted everywhere, and now I gotta clean up Dr. Jeff's equipment before he finds out.
How are you gonna do that? I mean, look at all this stuff.
I added hydrogen peroxide with dish soap in this container. So I'm hoping that by the time I add this catalyst, it'll cause a reaction, and soap bubbles will go everywhere, and I can just clean it up at once.
Okay.
Well, here goes nothing.
Well, I think that qualifies as tons of bubbles.
Look at this mess.
Hey, Dr. Jeff, I can explain. We were just...
This is fantastic.
It
is?
By combining 2 substances, you created a reaction, and that's exactly the lesson I wanted to cover today.
I knew that. That's why I did it.
Awesome. I'm Dr. Jeff Vineker, and today we'll explore the science behind chemical versus physical changes. But you still gotta clean all this up.
Oh, man.
We'll discover the differences between chemical and physical changes by mixing, burning, and blowing up our test materials. We'll show that both chemical and physical changes are all around us. Welcome to Labracazam, where we make science make sense. So, what do you guys think? Was Izzy's experiment an example of a chemical change or a physical change?
What exactly is the difference?
Good question, Zoe. In a chemical change, we form an entirely new substance. In a physical change, we don't.
So when we mix things together and a new substance is formed, it's called a chemical reaction.
Let's break it down. This is a banana.
12 years of college, ladies and gentlemen.
If I chop this banana into little tiny pieces like this, is it still a banana? Did we make a new chemical?
No, that's still a banana.
Which makes it a physical change.
Right. But what if we turn the banana into a shake?
Next, let's add those berries.
And now, the secret ingredient. Hot dog.
Well, it is a source of protein.
Go ahead. So, is this a new substance?
No, all the ingredients are just mixed together, so it's a physical change.
That's right. Now, it's snack time.
It's all yours, Izzy.
Hey, it's chewy, but it's pretty good.
Physical changes often happen when matter changes states. This solid spoon is made of a metal called gallium. Zoe, why don't you take the spoon and stir it into the very hot water?
When you put the spoon into the hot water, it causes it to melt.
Right? But the shiny liquid at the bottom is still the same metal. So it's not a new substance. And it's a physical change.
Correct. It also makes a really good prank.
Jeffrey! I said no more gallium metal in this house!
So those were physical changes. A chemical change is different. It forms entirely new substances. Hey Bert, do you have those chocolate candies?
Those were for an experiment? I thought they were for dessert.
Okay, how about that saltwater taffy?
Those were for an experiment too?
Is there any candy you didn't eat?
Yes, this gummy candy got stuck to my arm.
Thank you. This gummy candy is made of sugar. Let's see what happens when we toss it into this tube of oxidizer. That's a chemical that provides a lot of oxygen to help things burn. Don't try this at home. Here we go. Now that's a chemical reaction. The gummy candy burned up, forming entirely new chemicals, like this carbon. Gummy candy?
Oh, no thanks.
I'm actually pretty full from that hot dog shake.
Yes, please.
Now it's time to put our new knowledge of chemical versus physical changes to the test.
This first one is a classic, but with a twist.
A twist, get it?
No.
Anyway, we're going to need a drinking glass. Zoe, could you get one, please?
No problem.
For this science trick, you're going to need a bottle of soda, Mentos, fishing line, and scissors. First, you're going to poke a hole in the center of the Mentos and tie fishing line around it. Open up the bottle and lower it in, but don't drop it in. Now just put on the cap to hide the Mentos. And lastly, cut the evidence. Presto!
Oh my gosh, I can't wait to see the look on her face.
Don't try this at home or near any electronics.
Here you go.
Thanks, Zoe. Could you pour a glass of soda, please?
That's it? Really, Doc? Your experiments are starting to get a little bit...
This is everything I dreamed of.
Don't worry, Zoe. You're not the only one that fell for it.
Jeffrey, I said no more science pranks in this house.
So, was the foaming effect caused by a chemical change or a physical change?
Well, when you add the candy to the soda, it created a gas, so I say chemical change.
I think the gas is already trapped inside the soda, so when it's released, it's not a new substance. I say physical change.
Let's take a closer look. I'm gonna take a balloon and put the candy inside like this. Then I will put the balloon on top and allow the two to mix. If the gas we're collecting now is also carbon dioxide, then we did not make a new substance. I'll release this gas into this container. Hey Izzy, please light these candles for us. Carbon dioxide gas is heavier than air. So if you were to pour it onto lit candles, it would displace the air and the candles would have no oxygen, so they would go out. So Zoe, why don't you take this pitcher of gas and carefully pour it here on top of the candles.
I never knew you could pour gas you can't even see.
Whoa, so that means it really was carbon dioxide.
Labracazam. Conclusion. Combining soda and the candy released carbon dioxide gas, but the gas was already in the soda. That means it's not a new substance, it's a physical change. Don't try this at home. Let's try another one. This time, we're gonna use this yellow liquid and this zinc metal. I'm simply gonna take some of the metal and pour it inside. What do you think is happening?
Well, this must be a chemical reaction because there wasn't any gas. I mean, there's a lot now.
But maybe the liquid's just boiling, which will make it a physical change.
Both good theories. Let's try it out with a flame test. For that, you will need a flame. If this gas is carbon dioxide, it will extinguish this flame. If it is hydrogen, it'll make a little pop because it's flammable. And if it's oxygen, this flame will burn brighter. Let's try it out. I'm going to collect some of the gas like this. And once it's full, I'll bring it close to the flame.
It's hydrogen.
Hydrogen, a flammable gas less dense than air, often identified by the characteristic pop when it is burned in a flame test.
So we made a new substance. This is a chemical reaction.
Labracazam. There's a more exciting way to verify this, but we're gonna need a lot more gas. Back to the safety zone. Don't try this at home. I'm going to create soap bubbles of hydrogen gas using the hydrogen gas in this balloon and soapy water. Don't try this at home. Here we go. Izzy, I know you love bubbles, so hold up that tray. I'm gonna put a lot of bubbles in it. You got it. There. All right, Zoe, you're gonna light it on fire. 3, 2, 1. Labracazam!
That was awesome.
Can I be excused to go to the restroom, please?
Our test confirms it's hydrogen. Chemical and physical changes happen to us and around us every day.
To check out some more examples, let's cut to some real-world science. Here I'm whipping up egg whites to make frosting. Since I'm just mixing them with air, it's a physical change. When making toast, intense heat causes the bread to burn, which means chemical change. Hot chemical change. When you turn on a light bulb, the filament glows because it gets very hot, but no new substance is being formed. Physical change. Boiled milk! The sugars in milk called lactose are converted into lactic acid by microbes, making it sour and barfy. Chemical change. Now let's check in with Zoe with some do-it-yourself. This expired in 2012?
Today, I'm going to show you how to create a secret message using a chemical change. You will need Q-tips, baking soda, a cup of water, a measuring spoon, a regular piece of paper, and blackberries. Start by mixing 2 spoonfuls of baking soda into 1 cup of water. Give that a nice stir for about 15 seconds. It's okay if all the baking soda doesn't dissolve. Next, take your Q-tip and dip it into the liquid. Dab it off on the side of the glass and write a simple message in the middle of the paper. Then let it dry for about 10 minutes. It looks like there's nothing there, but when the water evaporated, it left streaks of baking soda crystals on the paper. The baking soda crystals are white, just like the paper, so you can't see it. To reveal the secret message, we'll use a chemical reaction. That's where the black
Hello?
Yeah, hello. We are having a network issue. The network just went off unexpectedly. Yeah,
Okay, yeah, that
I think
sounds
we
good.
are back online.
Okay.
So we can proceed.
Were you guys able
Hello.
to,
Hey.
yeah, so were you guys able to finish the video? Or I think we were pretty close to finishing it, but I wasn't sure where it was cut off.
I think
So,
you should continue with the lesson, the main lesson.
okay, I think if that is fine, we can continue with the slide. I only have a little bit of slide left, so we can finish this. So, yeah. We talked about the physical change, where no new substance is formed, and substance changes its size, shape, or state, but it still remains the same substance. So, we've talked about physical change examples. So breaking glass, mixing candies, shredding paper, folding paper, melting ice, chopping wood, cutting hair, and boiling water, and breaking egg are all examples of physical change.
Noise, okay?
So no new substance is formed during this physical change. But there's also chemical change, where new substance is formed. A substance transforms into a completely new substance with different properties, and this change is usually irreversible. And irreversible means not able to go back. Okay, so can everyone hear me okay?
Yes, yes, yes.
Okay,
I'm switching to a different
yeah, that sounds good. But if everyone can see my screen, I will try to finish up the lesson. Here, we're talking about chemical change, where new substance is formed. And this change is usually irreversible, meaning that it cannot be back to the original state. So burning wood is a chemical change. So wood turns into ash and smoke, and ash and smoke were not existent before, so it's a new substance formed. So it's a chemical change. Same with rusting. Iron and oxygen turns into rust, which is a new substance. Cooking, for example, turning a raw egg into a cooked egg, is a chemical change. And for baking, dough turning into bread is also a chemical change. A new substance is formed. Now let's get into review quiz. So these are some last couple example questions regarding physical and chemical changes. So the following processes are chemical changes except is it A, crumpling of paper, B, burning of wood, C, mixing of acid and a base, or D, rusting of iron? Which of these are not chemical change? So out of these choices, the answer choice that is not a chemical change is the crumpling of paper. And a crumpling of paper is a physical change. So does this answer make sense? The crumpling of paper is a physical change and not a chemical change. So all of these are chemical changes, but only crumpling of paper is a physical change. So that's why A is the correct answer. Now let's move on to this question. Which of the following processes is an example of a physical change? Is it the fermentation of food, respiration, magnetization of iron, or lighting a match? So chemical change happens when new substance is formed. And physical changes does not form new substances. So to give you a hint, fermentation breaks down substances into new chemical compounds. So this is a chemical change. Respiration, breaking down glucose and forming new products. So it's a chemical change. What about lighting a match? It produces heat, light, and new substances. So it's also a chemical change. Right? And C, lastly, only affects the alignment of iron. Magnetization only affects the alignment, and iron remains iron. So no new substance is formed. So it is a physical change. So the answer is C. So we have this next question. One similarity of physical and chemical changes is that both are they all easily reversible? Do they all result in change of state of matter? Or do they all produce no change of mass? Or are they accompanied by great heat change? So we are looking for similarities of both physical and chemical changes, right? And to give you a little hint, here at the bottom, you can see the law of conservation of mass. This is a big hint. So this states that mass remains the same in both physical and chemical changes. So the answer must be C, right? Produce no change in mass. So here on the bottom right picture is an example of how the law of conservation of mass takes place. So mercury oxide, 100 grams of mercury oxide produces 93 grams of mercury and 7 grams of oxygen. But you can see that 93 grams plus 7 grams all sum up to 100 grams. So no addition of mass was created. Mass remains the same across both physical and chemical changes. So that is why it is C. It produces no change in mass. It's a similarity of those physical and chemical changes. So is this clear for everyone? Does anyone have a question regarding anything from today's lesson? Because that was our last question. Does anyone have a question in maybe a question in, properties of matter? We looked at, matter, some properties, mass. We looked at volume. We also looked at density, how to find the density, magnetism, solubility. Then we moved on to, physical and chemical changes. Physical change, chemical change, and then we looked at some questions. So out of these, do any of you have a question for today? So if there are no questions, then that is it for today's lesson. And next time, I think you guys have a break for the next month, and we will be meeting again on September.
Yes. Yes. Yeah, that will be September. I think
Okay.
first week in September.
Yeah, we
That
will
will
be
be
meeting.
first week in September.
Yeah, that is right. I think September 5th will be our next meeting.
Yes. All right. Next week we'll be going on vacation.
Okay. Yeah, then
Yes.
have a nice summer break, and I will see all of
All
you
right.
on September then.
All right. Thank you too. Have a nice day.
Okay, you too. Thank you. Yeah, thank you everyone for listening today, and see you in September. All right.
Okay.
Bye everyone.